Oh, there it goes. All right, here we go. So sum and difference of cubes. And there's an acronym that some people use with this, and I'm going to teach it to you guys because I think it's helpful. The acronym is SOAP, which I will explain more in a moment. So for sum and difference of cubes, the way the problem is going to look is it's going to have one term cubed plus another term cubed, or it could have one term cubed minus another term cubed. So it's different than difference of squares because difference of squares has to have a minus. With sum and difference of cubes, you can do it either way. It doesn't matter what the sign is, okay? So the formula, if you have an addition problem, so if you have sum of cubes, the factors would be A plus B. So this is the S of SOAP. The S means you keep the same sign for the first factor, okay? Then after that, this first term cubed, you take that A value, whatever it was that was cubed, you take that and you multiply it by itself. So we're going to do A squared first. Then we have the O of SOAP, which is opposite sign. So we did same sign for this, we're going to do opposite sign next. The next term is what happens when you take the first thing that was cubed and the second thing that was cubed and you just multiply them together. And so this would be AB. And then the AP of SOAP means always positive. So this part right here is always a plus sign. And then whatever the B value was cubed, you're going to take the B value and multiply it by itself. All right, so that's our first formula. Now we're going to apply SOAP to the second formula. So if we start with a negative sign and the S is what we have first, and that means we keep the same sign, so we're going to say A minus B. And then we have O for opposite sign, so we're going to say A squared plus AB. And then we have AP for always positive, so we're going to say plus B squared. And those are the formulas that we use for sum or difference of cubes. All right, so we're going to go ahead and start off with x to the third minus 216. And typically the way I start these problems is I rewrite it as something to the third. So it's very common for them to have a variable here and a number there. And anytime they have the number, I have to think what number was it that they raised to the third power to get that. The numbers are going to be relatively small. So 216 is actually 6 to the third. So I'm going to rewrite this as x to the third minus 6 to the third. And that means that if we're comparing this back to our formula, that the A value is represented by x and the B value is represented by 6. I'm not thinking of it as a negative 6. I'm just thinking of it as 6. Okay? All right, so if we were to factor this, we're going to remember SOAP. So what should I put in my first set of parentheses? Same sign. So what am I going to put? You're close. X minus 6 because it's a minus problem. Good. And then what should come next? The A value times itself. X squared. Okay, so same sign. Minus, opposite sign. And then we do A times B. 6x, good. And then always positive. And then 6 squared, which is 36. Now this part right here looks like a trinomial where the A value is 1. And so we would say, is there anything that multiplies to 36 that adds to negative 6? And the answer, oh, that should have been a plus. Sorry, that was my bad. You guys had many heart attacks. You're like, we can't correct her. She's a teacher. She knows everything. One of the ongoing jokes between me and students who have had me for really high levels of math is that I have a mistake on every single answer key. It's not a question of if I have one, I do have one. Somebody has to find it. So we found it. This was the one. It's so awkward in here, you guys. It's so uncomfortable. So that was supposed to be a plus. So same sign, opposite sign, always positive. Yes?
Can you like repeat the what it means? So
the soap? Yep. Same sign, opposite sign, always positive. So same, opposite, always positive. So if we look over here, we have, it was a minus problem, so same sign, opposite sign, always positive. Okay. So if we think about that last part, if we're looking for what multiplies to 36 but adds to 6, nothing does. And when you're factoring sum and difference of cubes, 99% of the time that is the case. 99% of the time you cannot factor that. I would say there are a few exceptions, but generally not. Okay, so I'm going to be honest, when I do these problems, I usually am lazy and I don't even try because I know it generally doesn't work. All right, so that's the first one. I also want to try one where we maybe make it a little bit more complicated. So can somebody think of a perfect cube or use your calculator to find one? Something to the third power. Anyone know? A number to the third power? Or you could type it real fast. I know those cell phones aren't far away. You guys, we got to work on this awkward silence thing. Yeah. 512. Oh, what cubed is that? Wait. 8? Is that 8 cubed? Okay. So we'll do 512 x cubed minus. Anyone know what 3 cubed is? Starts with a 2. 27. Okay, we'll do this one. Minus 27y cubed. All right, so anytime you saw numbers, if they're big, you should always check for a GCF to see if there is one, always, all right, because we always take out the GCF. In this case, there is not a GCF, so what we're going to do next is we're going to think this is something to the third minus something to the third. And actually, I'm going to go ahead and switch this one to a plus problem since we just did a minus problem. Okay, so something to the third was 512. And what was it? 8. Okay. You guys were like, thank goodness we heard that because we never would have known. And then 27 is what? So we have 3y to the third. So that means that in this particular problem, the a value is 8x and the b value is 3y. So we'll keep that in mind as we're writing the factored form out. Okay, so the first set of parentheses, we're going to make sure we do the same sign. And what should we write? Yep. Perfect. And then we have the a value multiplied by itself. 64 x squared. Okay, and then what sign comes next? Minus. Good. Okay, and I got it right that time. It really is minus. And then we have to do the a value times the b value. 24xy. And then always positive. And then the b value multiplied by itself. 9y squared. Good. And technically I should try to factor that, but heck no. Not doing it. All right. How are we feeling about sum or difference of cubes? Relatively okay? All right. And then last one is we're going to go over grouping, factor by grouping. And factoring by grouping is actually one that you can use to factor a trinomial. So we are actually going to go back to that problem from the video that I already did twice. We're going to do that same problem for a third time so that you can see how to do it. And if you want to do it by grouping in the future, you're welcome to. So this is the one, we already did it with the box method and we already did it with slide divide bottoms up, and this is just a third method. And like I said in the video, I don't want you guys to feel pressured to use every single method. I want you to pick the one that you feel comfortable with, that you think you can remember. because the important part is just being able to do it. So when we factor by grouping, we still start with that part where we do 6 multiplied by the -2. So we're still saying that we're looking for something that multiplies to -12, but adds to -1, just like we did in the video. And what are the two numbers that do that?
-4 and 3.
-4 and 3. And then what we do when we factor by grouping is we take this trinomial and we make it a quadnomial? I don't know. We make it have 4 terms instead of 3. So we're going to keep the 6x squared, and we're going to keep the -2, but instead of leaving the middle term as just -x, we're going to split it into 2 terms, and the 2 terms are -4x and +3x. So when you add those together, those still give you -x when you add them together. We're just splitting it apart. And what that does is it gives you a polynomial that has 4 pieces, and now we can split it down the middle and we can factor it by grouping. So I grouped the first 2 terms, I grouped the second 2 terms. And once you have grouped them, then you look for the GCF. So between 6x squared and 4x, what's the GCF? 2x. And what would the leftovers be? 3x minus 2, okay? And then over here, is there anything in common? No. So what number should we use? 1, good. And then our leftovers would be 3x minus 2. Okay. So this is the part where grouping feels a little bit weird. Now we're going to say this is one term, and this is the second term. So 1/2, the other half. And we're going to ask ourselves what's in common between the 2 halves. They have those parentheses. We're going to take these parentheses out like a GCF. So this is the greatest common factor. So I'm going to take out my GCF of 3x minus 2. And then I write my leftovers. And my leftovers are a 2x and a +1. So I got the exact same factors I did when I watched the video. I just did it by grouping instead. All right. So with a trinomial, using the method of grouping is optional. There's also problems where you have to do factor by grouping. It's not optional. And those are problems where they started off with 4. So if we have a problem like 8y to the 3rd minus 7y squared minus 64y plus 56, this problem, it wouldn't matter if you hate grouping. You have to do it because there's no other way. Okay, so notice here those middle 2 terms, they're not like terms. You can't combine them and make it into 3. It really is 4. So again, we're going to split it down the middle. And then we're going to look for a GCF between the first 2 terms. Y squared, yep. And when you take out that y squared, what's left? 8y minus 7. All right, and then between the second 2 terms, what's the GCF? I heard it, maybe? 8. And then if we take out the 8, what's left over? Now, if you remember the last one, we wanted the parentheses to be the same, right? So this is not quite going to be the same. How should we fix it?
Negative.
Yeah, take out a -8, and then that makes this a +8. So now we can see our parentheses are going to be the same. If you have a +56 and you divide out a -8, what do you get? -7. All right, so anytime you're doing a factor by grouping problem, if this term is negative, take that negative out with it. All right, so we have our GCF is 8y minus 7, and then we have our leftovers, which are y squared and -8. Can we factor this anymore? No, because it's not a perfect square. Okay. Technically, you could factor it. You could say y plus square root 8, y minus square root 8, but we don't typically expect you to do that. Okay, so there's our last one. How are we feeling about factoring? Maybe not amazing, but a little bit less rusty, hopefully. So since factoring is such a big thing in math, like at this point, it's very, very common. It shows up all the time. You want to make sure that these notes especially are somewhere like near the front of your math notebook always, just because you don't want to have to be flipping and turning through things to find it. All right?